Okay, we're going to get going on some calculus here. Topic 7, Introduction to Differential Calculus. First section here is differentiation and finding a derivative. Okay, so a derivative of a function is basically, it's a way that gives you the gradient of a slope of a line that is tangent to a particular function. So this might be a function here. It happens to be f of x or y equals, it's y equals 1/2 x squared. Okay, now this line here is tangent to it. If we want to find the gradient of this line, we take what's called the derivative. Okay, now what we're going to learn today is, or go over, you've probably already learned it, is how to find this gradient, how to write the equation of this line, and look at maximum and minimum points, things like that. So whether it's a function is increasing, like here. At 0, the function, at the bottom of the function, it's not increasing or decreasing. It's 0 right here. The gradient would be 0, because if you drew a tangent line, it would be straight across here. It would be 0. Any horizontal line, m equals 0. Okay, now, but up here, you see that it's increasing. Okay, the function's increasing. Here, the function's actually decreasing down here. Okay, so we'll get into that a little bit more, but it's always nice to illustrate on a graph. Okay, so the first thing you need to know how to do here is you need to know how to take a derivative, okay? And I'm not going to go through proving it by first principles and all that stuff. At this point, there's really not the time. So it's written a couple of different ways. So like if you have something like y equals 2x to the third power plus 5x squared plus, I don't know, 2, let's say. Okay. Now, if we're going to take the derivative of that, like dy over dx, what we do, all you do is you multiply the exponent times the coefficient, so 3 times 2, which is 6, and then you take 1 off the exponent, so that would be 6x squared, plus 2 times 5 is 10x, and then if there's no x there, that's nothing. So this is our derivative function right here. Okay, now what we can do is, let's say at x equals 1, what if we want to find the derivative? So, at x equals 1, we would just sub it in. So 6 times 1 squared plus, 10 times 1. So that would be, with this function is going to be increasing quite rapidly because you have x to the third power here, you have x squared here. So, at x equals 1, the gradient would be 16. Okay, so that's one way to write it. Okay, you also see it's written in function form, so you might see something like this: f prime of x, or let's start with f of x. Okay, and let's just make a function. So let's say we have 3x squared plus 2 over x to the fourth power. Okay, now. This one, when you take the derivative, they do what's called f prime of x. Okay, so that's taking the derivative. That's the same thing as this. It's the same notation. So a lot of this, you just have to look at the notation. Now this, 6 times, again, okay, well, I'm all about the 3's and the 2's today, huh? 6x, and then plus, now, if you look at this, or actually I shouldn't even write a plus right now. I can. Okay, so 2, but like x to the fourth, it's on the bottom of a fraction. So the way you can rewrite that is with a negative exponent. So x to the negative 4. So in order to simplify this, we have 6x. We've already simplified that one. And this would be minus 8x. And then if you take 1 away from that, it would be to the negative 5th power. Okay, so that's the only tricky part with these. When you have the negatives right here, they go down by 1, so it goes to negative 5. And if I wanted to rewrite this in the best form, I would do 6 minus 8 over x to the 5th. Okay, I always, if you're good enough to know, just to bring it down 1, you can leave it. But I always like to bring this up and make this 2x to the negative 4, just so, to me, that's easier. You multiply that. Negative 4 times 2, and then you get the negative 5, and to me that's a lot easier. Okay, and so that's your derivative function there. Now, if you know how to take a derivative, and it's really not that hard, you just follow that straight rule. That's half the battle in calculus, because that's where all these problems start. Okay, so maybe work on that a little bit. Hopefully this helped you out a little bit. So let's do a couple problems now and test it out a little bit. Okay, so for the first problem here, it says differentiate that means take the derivative of the function y equals x squared plus 3x minus 2. Okay, no problem. So, what we're going to do here is dy over dx equals, well, if there's nothing in front of it, just write a 1. It's 2 times 1, and then take away 1, so it's going to be 2x. Now, if there's no exponent, you can write a 1 there. So 1 times 3 is 3, so it's going to be plus 3. And then it becomes x to the 0 power, which is 1. So anytime it's just an x, it disappears. So this is our derivative function right here. So any x value we put in here, we're going to get a gradient. Okay? So that's pretty straightforward. Now, let's see how they work this. They say, at a certain point xy on this curve, the gradient is 5. Find the coordinates of this point. Okay, no problem. So what we do here, they give us the gradient. They give us this. So all we have to do is sub in right here. So we just do 5 equals 2x plus 3, and then just use algebra to solve it. Okay, and so you get 2 equals 2x. So x is going to equal 1 in this case. Okay. Now, how do we find the y coordinate? Well, we know the x coordinate. Now, in order to find the y coordinate, we just have to sub that back into the original function. So, y is going to be, 1 squared plus 3 times 1 minus 2. Okay, so that's 1 plus 3 is 4 minus 2 is y equals 2. Okay, so if we're going to look at our coordinate here, remember you always write it with brackets. 1, 2 is our coordinate. Okay, and that's a pretty straightforward paper 1 problem right there. Okay, let's try another one. Okay, so for this problem, it's a little bit different, but same concept, I guess. It says a function f of x is defined as f of x equals 3x to the 4th plus 2 over x minus x over 4 plus 1, where x isn't equal to 0. Okay, no problem. Calculate the second derivative. Okay, the second derivative, you don't really need to know what it is. It would basically represent the acceleration in, I don't know. I'm not even going to go into it. Basically, what you do is you take the derivative twice. Okay, so if I'm going to rewrite this first as f of x equals 3x to the 4th, and then my little trick, I'm just going to make it 2x, and then there's only 1 down there, so negative 1. Now, x over 4, okay, that's the equivalent of minus 1/4 x, and then plus 1. Okay, now this is going to be a lot easier to take the derivative when we do this. Okay, so let's take a derivative. 4 times 3 is 12. Take 1 away. 12x to the 3rd. Negative 1 times 2 is negative 2. And then remember, it goes down. So it's going to be x to the negative 2. And then it's going to be, negative 1/4. And then since it's just x, it's done. And then any number you don't have to worry about all by itself. Okay, so this is our derivative right here. However, they want us to take the second derivative, so we got to go ahead and do it again. So they're being a little tricky here. So 3 times 12 is 36. Bring 1 down. And then negative 2 times negative 2 is plus 4. And then it's going to be x to the negative 3, right? And then 1/4, it goes away there. So it's kind of nice because we got rid of 2 of the terms here, okay? Now, I'm going to rewrite that just in, simplified form. Now, you could leave it like this if you want to, but I find it easier to do the problems if it's like this. Okay, so find the value of the derivative at the point 1/23 over 4. Okay, well, all we have to do here, if we have the second derivative here, all we have to do, this is kind of a trick, all you really need for this is 1. So we'll just do f, the second derivative of, we won't do x, we'll do, I'm using the eraser, I'm trying to be more neat. Yeah, should have started that about 35 videos ago. Okay, so 36 times 1 squared plus 4 over 1 to the 3rd power. Okay, so that's just what? That's 1 times 36, 36. That's 4 over 1, so the 4. So this equals 40. Okay, so the second derivative of 1 equals 40. Okay, and we're all done. Okay, so what you need to take out of this first section is you just need to be able to take a derivative, especially with negatives. If you can do that, honestly, you can get quite a few marks in the first part of these paper 2 problems. Now, what we're going to review next is where these problems go. They get a little trickier after this, but you know, whatever. We'll roll through it, okay? So hold on just a second, and we'll move on to the second section. Okay, for part 2 here, we're going to do equations of tangent lines and values of x when f prime of x is given. Okay, so remember, the equation of a tangent line is the equation of a line that touches the curve at exactly one point. Its slope is the derivative. Okay, we found the derivative in the last, its slope or gradient is the derivative. We did that in the first section. Derivatives can be used to find slopes of tangent lines. In the reverse, they can find values of x for the given gradient or slope. As a slope of the tangent line at a local maximum and minimum is 0, this is a common way for this to appear on examinations. So let's look at this function. I just made this one up here. You know, look at what's going on here. The function is increasing, and then, you know, at 10, it's, you know, it reaches 0. Okay, that's a local maximum right here. Now it's decreasing, and that, you know, if you want an equation of that, you would just put y equals 10, because that's a horizontal line. And then, you know, it goes down to the minimum here, which is, I think, it's kind of hard to read, 22, so negative 22. So this would be, you know, y equals negative 22, okay, if we were going to do the tangent line there. Okay, so anytime you want to do a horizontal line, you're going to have to write equations for horizontal lines. It's y equals. If you want to write an equation for a vertical line, it's x equals. Okay, and then again, it starts to increase here. So oftentimes what these problems will ask you to do is give the interval where this is increasing, decreasing, etc. Well, okay, so let's just, you know, let's do that. So you know, if x is less than, hits the maximum at 0, you know, it's increasing. Okay. Now at 0, it, you know, that's a local maximum. Okay. Now from, you know, x is greater than 0 to less than, what is this, 4? It is, you know, decreasing. Okay, the function's going down. Okay, so you can kind of just start with your pen and just like whoop, whoop. Okay, it's going down, and then, you know, at 4, you know, it's a local minimum where the gradient is 0. Okay, and then you know, it's increasing from when x is greater than 4. You know, it's increasing. Okay, now I've got a little ahead of myself here because that's what the next section does. But you know what the hey, I start it, so why not finish it? Okay, so anyway, let's do a problem. Let's see what we got going here. Okay, this is a paper 2 problem, and you know, it says the diagram below shows a graph of a line L passing through the points 1, 1, and 2, 3, and the graph P with the function f of x equals x squared minus 3x minus 4. Okay, so we have L right here, we have P. Okay, great, no problem. Okie dokie, let's see what they ask us to do. Find the gradient of L. Okay, well, a lot of times they'll incorporate regular, you know, coordinate geometry or algebra into this, and so, you know, we would just use, anytime you want to find gradient when you have 2 points, you know, it's y2 minus y1 over x2 minus x1. So in this case, it would be 3 minus 1 over 2 minus 1, which is 2 over 1, which is 2. Okay, so that's our gradient here, so m equals 2. Okay, so my guess is we're going to need that. Okay, now differentiate f of x. Okay, no problem. So f prime of x, and we'll just differentiate this. So we get 2 times 1 is 2x, and then again it's minus 3. Okay, so this is kind of similar to the problem I did before, but it gets a little more complicated. Okay, now find the coordinates of the point where the tangent to P, okay, so the tangent line to P, wherever that is parallel to line L. Okay, well, if it's parallel to line L, it has to have a gradient of 2. Okay, now remember, this gives us our gradient. So if we know what the gradient is, we can sub it in here, into right here. So we can say 2 equals 2x minus 3 to find the x value. So plus 3, and so we get 2x equals 5. So, x is going to be 2.5, okay, or 5 halves. Okay, so now they want the coordinates of the point. So to get y, we're just going to have to sub it in to the function. So, we would just do, 2.5 squared minus 3 times 2.5. I'm just subbing it in right here, and minus 4. Okay, so what do we get if we do that? Let me see here. I think it's negative 6.25 or something like that. I can't remember. Obviously, I've done this problem before, but I can't always remember the answers. Okay, 2.5 minus, actually, come to think of it, I don't ever remember the answers. Okay, even though I'm a dork and I make math problems at home for fun, it doesn't mean I remember the answers, okay? All right, I'm just kidding. It's late, I'm talking to myself. Okay, negative 5.25. Okay, so negative 5.25. All right, so our point here is 2.5, negative 5.25. Okay? And that's our coordinate there. Now, I'm going to have to scroll down to do the rest of this problem. Hold on just a second. Okay, so part D here, I just pasted on some stuff here. I had to move it down, so I might have to go up back and forth here for a little bit, which is unfortunate, but we'll deal with it. Find the coordinates of the point where the tangent to P is perpendicular to L. Okay, well, if the gradient of L is 2, if it's perpendicular, it's a negative reciprocal. So we just flip it over and change the sign. So it's going to be equals negative 1/2. That's the gradient. Now, we do the exact same thing we did here. We've already found the derivative right here, so we can just do now negative 1/2 equals 2x minus 3. Okay, so you plus 3 over here, and you get 2.5 equals 2x. So x is going to equal 1.25. Okay, now again, all we have to do is sub 1.25 in here, okay? And I'm not going to waste your time and do that. All you do is sub it into the original equation just like we just did. So let me write down the answer. I think it's negative 6.5 or something. Hold on. Okay, so it's, the y is going to equal negative 6.1875. Okay, so I was close. So again, if you want the coordinates, you just write your point, 1.25, negative 6.1, and we can even put 1.9 if we want to 3 significant figures. But if you got the mark scheme had this exactly, so I don't know. I assume you can do both. Okay, the gradient of the tangent to P at the point where the coordinates 2, negative 6. Okay, well, all we have to do here is plug in the 2 into the gradient, or into the derivative, sorry. I mean, some of these are pretty straightforward. You just kind of have to, the math is easy. You just have to know kind of what to do. So if you do 2 times 2 minus 3, we plugged it into, hold on just a second. Just so you know here, this is the most important thing we're using right now, okay? So I just plugged 2 into there, and so you get 1, okay? So it equals 1. All right, now the equation of the tangent to P at this point. Okay, so this is M, okay, and let me give myself a little room here. This is the thing, like, this is an algebra problem now. I mean, or coordinate geometry. I'm used to calling it algebra, but in studies they call it coordinate geometry. Whatever, same thing. So we have M equals 1, and then we have the point 2, negative 6. Now, this is how you write an equation of a line. If you have y equals mx plus c, okay, we have 3 of these data points. This is the x right here, and that's the y. So we just sub it in, and we'll find c. So negative 6, m is 1, 2 plus c. Well, that's going to equal negative 6 equals 2 plus c. We'll move the 2 over, and you get negative 8 equals c. Now, once you have m, and once you have c, you can write the equation. Y equals 1x. Well, okay, so you wouldn't write that. You'd just write x minus 8. If you wrote 1x, it wouldn't be wrong. And you just, boom, like that. Okay, and there's your equation of the tangent line right there. So, like, look what we've done here. The calculus we've done is this. which was pretty straightforward, taking the derivative, and then look what we've done since then. It's all been plugging in numbers and just, if they, I don't know. I guess you kind of have to do a couple of these to see how they work. But so far it's been pretty straightforward, hopefully. And I've also made some other videos on these, so if you need to look on more, I'll link to them. Okay. But let's finish this problem. I get off track. Sorry. Okay. So the last thing they want to do here is, and I brought the graph down just so we can look at it. Okay. And you know what I should have done is I should have brought the equation down too. I will do that too. Hold on just a second. Alrighty, now I think I'm ready to go. Okay, so state the equation of the axis of symmetry of P. Okay, well P is the parabola here. I cut it off a little bit so I could fit it. Okay, again, this is not calculus. This is the axis of symmetry is in your formula booklets. Is x equals negative b over 2a. So we would do, well, we have negative 3 here, so it would be negative 3 over 2 times 1, because there's nothing in front, it's just a 1, right? So it's going to be 3 over 2. So that's our axis of symmetry right there. And if whenever they say the equation, make sure you write x equals. So x equals 3 over 2, or you could put 1.5 if you want. I like to leave them as fractions personally, but whatever. Okay, find the coordinates of the vertex of P. Okay, so they want the vertex here. Okay, well again, all we have to do is sub in 1.5 or 3/2, so into f of x. So f of, I'll do 1.5. I just said I liked fractions, and now I'm using decimals. Wow. Whatever. So anyway, if you figure this out, let's see, we'll break out the calculator. And okay, so I think this is where it's negative 6.25 or something. 1.5 squared minus 3 times 1.5 minus 4. Okay, and that, negative 6.25. Okay, so negative 6.25. Okay, so our our vertex there. So the vertex here is going to be 1.5 negative 6.25. Okay. Now, what's the gradient at this curve? Well, okay, I happen to draw a nice tangent line here. The gradient is 0. Okay, so m equals 0 because it's a horizontal line at your minimum here. Okay. Now, anytime they want the coordinates of the vertex, let me just show you why we have this up. I may have done this in the geometry or function video, but maybe not. I can't remember. Just type it in here: x squared minus 3x. Calculator work is so important in this class. If you know what you're doing on the calculator, it's just going to help you. And then you just graph it. Okay, so there's our function. Well, we can calculate the minimum, okay, or the vertex. So we'll go. It's the same thing. So the minimum here, we just press enter. Okay, so it says left bound. So just go to a little to the left of the vertex and press enter. And then it says right bound. Go to a little bit to the right of the vertex and press enter. Okay, and then it says guess. Sure, guess it. Boom. You better guess it right. Good. 1.50 negative 6.25. Okay, cool. So that's one thing. This second calc button is just great. You can do values of x. Or put in values of x to get y's. You can calculate where it intersects with the x-axis here. Minimum, a maximum will be if it's upside down. If it went whoop like that. Intersection, if you have two things, like if we wanted to calculate this point here, we could calculate the intersection. Actually, you can calculate the derivative too, or that's the gradient. But we won't even deal with that. You don't need to use that. Okay. So anyway, that's part 2 of this. I know it's kind of long, but a lot of stuff going on here. But hopefully it helped you out. And what I will do is I will link right now to those other videos, calculus videos, just so you can get some more help if you need it. Okay. One more section in here though, max and minimum. Okay. Okay, finally the last section here, we go increasing, decreasing function, maximum, minimum problems. Okay, remember on the last one, I kind of took some of the buzz out of this when I actually did it on the last section, but whatever. A function is considered to be increasing when its slopes is positive. So, you know, the slopes are positive like right here, the slopes are positive right here. You know, so, you know, the green here, or actually black, I forgot I opened up a new one. So black would be, you know, that's increasing, okay? Um, and then if we, you know, if we change the color a little bit here, what do we want? Let's see, let's go with some green. Decreasing would be, you know, when it's the negative slope, like down like this, okay? And then let's go for, I don't know, how about some blue? You know, your maximum and minimum points right here, that's where your gradient is going to be equal to 0. Okay, so remember that's a maximum point and that's a minimum point. Okay, and if you know, need to write the equation of that, you know, y equals 10, you know, y equals negative 22. In those cases, m equals 0 and m equals 0. Okay, you know, you can read through this. I think we're all good on this. I don't know. Forgot to write decreasing here. Okay. Wow, my handwriting's falling apart. Okay, so, you know, I'm obsessed with my handwriting. I've noticed that, and some of the students told me about that. And I will try and improve on that. Okay, so let's try a problem here. Okay, so this would be like a typical paper 1 problem, maybe 1 point apiece. Okay. And it says, given the graph of f of x, state the intervals a through L where f of x is increasing. Okay, so what we want, you know, I'm going to do increasing. I'll just, you know, I'll do with the red or whatever, pink, whatever this is going to turn out to be. Okay, so when does it have a positive slope? Okay, well, right here. Okay, so from B to D. Okay, and you can just write it like that. And then, okay, it's negative, negative. Okay, it's 0 there. Then it goes positive here. So, you know, from G to K. So it's going to be multiple spaces. Okay, and then the last one would be, you know, from K to L. Okay. So that's all the positive ones. Okay, the interval is a to L, which f of x is decreasing. Okay, no problem. Let's do decreasing. So decreasing, well, we have a to b right here. So that's going to be decreasing. Okay, and then how about d to e? Like right down here, it's decreasing. Okay, so d to e. All right, you can just write it like that. A point which is a maximum value. Okay, well, the maximum value is, again, you know, up here. So it's just going to be d. Okay, and then a minimum value. Now there happen to be 2 minimums here. Okay, you could put b and you could put g. I would put g personally because it's lower, but whatever. In either one, they're both local minimums, so you really wouldn't have a function like this usually, but whatever. And then finally, the name given to point k where the gradient is 0. Okay, well, when you have a function that's going positive like this, and then it hits 0, then it keeps going positive, it's actually called a point of inflection. Okay, and that's I don't know. That's just this is the only time I've ever seen this, so I don't know how much you have to know that, but yeah, that's what it's called. Okay. Anyway, don't know what else to tell you. Okay, so let's do an optimization problem and really get this going. Okay, so it says a rectangular piece of card measures 24 centimeters by 9 centimeters. Each equal squares of the lengths x are cut from each corner of the card as shown in the diagram below. What is left is folded into an open box of length L times width. Okay, no problem. Okay. Write the expression in terms of x for L. Okay, so let's just call this the length and this the width here, okay? Now, this whole thing is 24, right? Now, what we're actually concerned about, oh gosh, let's get some color in here, dude! Okay, what we're concerned about is this right here. Well, it's 24, and what are you taking out of it? An x and an x. So what I would put here is 24 minus 2x. Okay, same thing with the 9. Okay, the whole thing's 9, but you know, if we just look at that part, it is going to be, or actually they're going to cut it right there. It's going to be 9 minus 2x. Okay, so that's what it is. Okay, now so if you're going to look at what they're going to do here is they're going to fold this up along here. Okay, and it's going to be what they say, an open box. Okay, so they're going to fold the sides up. Okay, or actually, sorry, this is going to be like this. They're going to fold this up like this. Okay, so and then they fold it up. I don't know. It's kind of hard to imagine right now, but imagine that all this right here is folded straight up. Okay, if you can. I don't know. It's kind of a weird drawing. Okay, so show that the volume b to the meters to the cubed of the box is 4 x to the third minus 66x squared plus 216x. Okay, no problem. Well, that's just, remember, we already have this one. It's 24 minus 2x. We have this one, which is 9 minus 2x. And then for volume, we need the third. Well, when we flip this up, what's it going to be? It's going to be x. So we can just do this right away. So we just do 9 minus 2x times 24 minus 2x times x. And you have to show this out. Okay, so I'm just going to use a calculator on my own. 9 times 24. Okay, so we get 9. Here, let me use a different color. Okay, I'm going color crazy on this one. So it's 216, and then 9 is negative 18x, right? And then negative 48x, and then it will be plus 4x squared, right? Now, we got to multiply all that by x. And so we get 216x minus 18x squared minus 48x squared plus 4x cubed. Okay, now we can simplify that. So 4x cubed, what do we have with the x squared? So negative 18 minus 48 is negative 66x squared, and then plus 216x. And then that's going to be meters cubed. Okay. That should equal that. Does it? Yeah. Okay, we're good. So there you go. You showed your work. You're good to go. Okay. Now, let's scroll down here. Hold on. Okay. Now it says find dB to dx. Okay, so we're just finding the derivative here. So what this is going to be is just the 3 times 12 or 3 times 4 is 12. X squared minus 132x plus 216. Okay, so at this point, hopefully you guys are experts at taking the derivatives. Okay, find the value which gives the maximum volume of the box. Okay, well, anytime they do this, okay, all you have to do is set the derivative equal to 0. Okay, because remember, when we have a maximum like this, the gradient is going to be equal to 0. Okay, so we just, no problem, we've got a quadratic here, right? So it's going to look, it's going to look, well, this one's going to look like that. So, interesting. Okay, but that's the derivative. Oh, actually, we have a cubic here. Okay, so no, we're good. Okay, so I'm just going to make it equal to 0. So 0 equals 12x squared minus 132x plus 216. Now, the reason I like this problem is because now you see this and kids go, oh my gosh, what do I do? Well, you should know, right? You go straight to your apps, okay? And it's a quadratic, so you want to solve it, right? So you go to polysimultaneous. You go to, please get, poly root finder. Get, get your calculator updated to this latest edition. It's I can't remember exactly which one it is, but I'll look in a second. 3, 2, and then what, 216? And what do we got? We solve it. We get 9 and 2. Okay? So, x is going to be equal to 9 and 2. Now, we have two answers. Which one of them is going to work? Well, we can't sub a 9 into here. Let me rewrite those. We have 9 minus 2x times 24 minus 2x times x. Okay, we can't sub a 9 in there because that's going to give us a negative number. So we're going to have to sub the 2 in. Okay, so let's sub a 2 right here. So it's going to be 9 minus 4 times 24 minus 4 times 2. Okay, so that's what, 5 times 20 times 2. Okay, so calculate the maximum volume. Boom. Well, okay, so this answer is 2 right here. And then this answer, maximum volume, is 200. And it's meters cubed. All right, sweet. Okay, that was a pretty good one. Okay, so we're just going to do one more here. This one's pretty tricky. But, you know, let's do it. Let's give it a shot. A farmer has a rectangular enclosure with a straight edge running down one side. The area of the enclosure is 162 meters squared. Okay, no problem. Okay, so this is X right here. Okay, he encloses this area using X meters of hedge on one side as shown on the diagram below. Okay, well this is X, but this is X because it's rectangular, right? So it's got to be on the same side. Okay, if he uses Y meters of fencing to complete his enclosure, show that Y equals X plus 324 over X. Okay, now this one is a little tricky. Okay, so what we have to do is we have to use some crazy algebra here. We have to this side right here and this side right here, we got to give it a variable. Now they've already used Y here, so we got to use another one, and we can use Z, or if you prefer Z. Okay, I'm American though, so I say Z. I don't know, whatever. My Canadian friends say Z, so there you go. All right, so what we can say here is, well, if the area of this is 162, isn't X times Z 162? And then, you know, what we can do is just solve for Z here. See, notice how I'm switching back and forth. This is funny, huh? Okay, Z equals 162 over X. So, you know, this is 162 over X, and this side is 162 over X. Okay, so now they want to know what the if he uses Y meters to complete the enclosure. So they're saying this is Y meters. Well, it's going to be Y equals X plus 162 over X plus 162 over X. So Y is going to equal X plus 324 over X. Okay, so I get that that's a little tricky, but here's where you got to use strategy. If you don't know how to do that, and a lot of kids would have a lot of trouble doing that, creating a new variable, that's fine. You can skip that part. You'll miss out some points, but you can use this for the rest of the problem. Okay, so don't give up on this problem. Okay, so the farmer wishes to use the least amount of fencing. Find dy to dx. Okay, so they want you to find the derivative. Okay, so you guys can do that. So we have this is 1x, so it's going to be 1, and then let me rewrite it. X plus 324 to x to the negative 1. Okay, so it's going to be 1 minus 324 over x squared. Okay. Okay, so I took that down one and I just simplified it. Hopefully we're to the point now where we can do that. Okay, now find the value where y makes a minimum. Okay, so when we're talking about minimums, remember it's down here, so m equals 0. Well, we just took the derivative, so just go 0 equals, all these problems work the same. 1 minus 324 over x squared. Okay, now what I would do with this, quite frankly, is I would go to the solver right away. Okay, this is another great tool. Okay, and you turn the calculator on, you go to math, you get on the home page first. See, that's the problem with simultaneous. It's tough to get out of. But once you're out of it, okay, we go to math. Arrow up, and you go to solver. And then anytime something's equal to 0, you can just type it in. So 1 minus, and I'm anal about brackets, so you don't actually have to do it, but I would. And you never know. For this problem you don't, but for some you do. So I would just do it like that. And you press enter. And then it's going to say your x value here. That's not the answer. Okay, you have to do alpha and you have to press enter. You see where it says in green solve there? So boom. Okay, 18. So in this case, x equals 18. Okay? All right, that's the value of y that makes a minimum, no problem. Now, calculate the minimum value of y. Okay, well, again, we can just go back to the original equation here. X plus 324 over x. Now, what's x going to be? We'll just sub in 18. So y equals 18 plus, 324 over 18. Okay, well, 324 divided by 18 is 18, I think. Okay, so it's going to be, y equals 18 plus 18. Okay, which is 36. Okay, and there's your minimum value. And do not forget to put your units. Okay, so there you go, guys. That and gals. That was a long slug. That's a lot of calculus we did, and I've got a couple other videos that will help you out. I mean, I think most of these problems work the same way. Okay, so make sure you can find the derivative. First of all, make sure if it's a maximum or minimum, you make it equal to 0. Make sure you can write the line, equation of a tangent line, and you can get through these. Okay, it's only about 15% of the exam, so even if you only get half of them right, it's still not too bad. Okay, so anyway, take it easy. Part 8, topic 8. Last topic is coming up tomorrow, though. I'm gonna need to go to bed. Okay, take care.